My dear friends, welcome to Rajshekar classes on applied data science with Python. This is lecture number 465. In this lecture, we will try to understand A-B testing. So, A-B testing is very important part of machine learning and in general science. We will discuss couple of examples of where A-B testing used in the real world. It's very important part. This is as important as modeling itself. This is often referred to as, in some literature or in some blogs or in some Wikipedia articles, this is called as bucket testing, or this is also referred to as split run, or it is also called as controlled experiment in science. So to understand this, let's take an example. I will give an example from medicine. I will give an example from medicine to start with. Let's assume there is new medicine. Suppose there is a medicine for cold. Let me assume there is a medicine for cold. Suppose there is a medicine that is already existing. Let's call this is M old. And some company created new medicine or drug that is M new to address the problem of cold. Now, before the government or regulatory agencies decide whether the MU drug should be approved or not, they need to test it and compare with existing drug. And additionally, they should compare with given no drug. They give you drug, but there is no chemical at all. This is called placebo. What is this? This is called placebo in medicine. So they compare new drug with existing drug and with placebo drug, which means there is no medicine in this, isn't it? Placebo drug means there is no medicine in this. It is just an empty capsule with some sugar filled in it, or just an empty capsule with nothing to resolve cold. So now what happens is, let's take a bunch of patients or users. You break these users into two groups. Let's call them group A and group B. Group A is given old medicine, group B is given new medicine. Group A is often called as controlled and group B often called as treatment. And these words control and treatment are found in medicine. Let's assume there are 100 patients. 50 patients are given to group A and 50 patients are given to group B. 50 patients are taken old medicine, and let's assume they recovered in 2 hours, and 50 patients are taken the new medicine, and I randomly split these 100 patients. From the group of 100 patients, we randomly split into two groups, and the patients are taken new medicine, and let's assume they recovered in 1 hour. That shows my new medicine is more effective. This is a real life test. This is not a chemical test saying, okay, my new medicine has some chemical, that's why it is better. This is a true test. So now let's look at this. The makers of new medicine, MNU, can claim that the new medicine will resolve your cold problem or cold issue in half the time as the old medicine. Of course, instead of the old medicine, they also tried no drug. Probably it takes 8 hours cold to go away. So this is how actually they test the medicine. This is how US Food and Drug Administration actually test medicine. any drug or any medicine, any US Food Drug Administration actually test medicine, any drug or any medicine thoroughly, not on 50 or 50 patients, 100 100 of patients, in some cases thousands of patients, before any new medicine is approved into being used by regular patients or our customers, isn't it? So A/B testing is very important concept in whole of science, especially medicine. Now you will wonder how is A/B testing is useful in machine learning. Let me give you an example. Let's assume you are building. Let's assume you are building a model for Google to predict which ad to show for search query, which advertisement to show for search query. Remember, when you actually go to Google and when you search on Google, if you type search and enter, Google gives you a bunch of results, and it also shows some ads, some advertisements. It shows couple of ads that then you will get. Let me assume I entered search, but let me assume I searched for something. Let me assume I have got two advertisements, ad 1 and ad 2. Google makes billions of dollars using these ads. When anybody clicks on these ads, so when anybody clicks on this ad, if I click on this ad 1, the person who plays this ad, or company or the website who plays this ad, will pay some money to Google, and that's how Google makes billions of dollars. There is also one of our case study to predicting which ad to show to which user. This problem can be posed as machine learning problem. Now comes a fun part. Let's see how it works. How does A/B testing work in this case? Now let's say you have a millions of 1 million users. Okay, you have a bunch of users. Now we'll break randomly these users into two groups, group A and group B. Let's assume there is an old model MWorld that is already existing, with people are very happy with that. Now you come and say, I have trained a new model MNew, and it tested it offline, tested it on t-test. Again, this t-test comes from previous days data. You train the model and tested it. This is called offline testing. This is also called as online testing, because you are actually testing in the real world. You are actually testing in production. You shown that your new model is performing better than old model in all my analysis. Then to be really sure that it works, you have to actually put it in production. So what they do is they break up all the users they have into two groups. Let's say they broke it up into 90% of users into group A and 10% of users going to group B. On group A, you deploy old model. On group B, you deploy new model. Now you might wonder that why are you splitting users into 90% and 10%? Because I know that my old model works very well. If I split them into 50% and 50%, and let's assume my new model is somewhat crazy. If I split into 50-50, let's assume I have 1 million users. If I send 500,000 users into old model and 500,000 users into new model, if my new model is crazy, then 500,000 users will suffer because of it, and no company wants to do it because of it, and no company wants to do it. What we often do is we say, let's not send very large amount of traffic or large amount of users to the new model. Let's send a small percent. Let it be 10% of customers. Let's send them to new model. And here I will compute the number of clicks and the number of ads I have shown. Similarly here I will compute number of clicks and the number of ads I have shown in the case of A and in the case of B, isn't it? And what is the metric here to compute these two, to compare these two models? Let's the metric is called click-through rate, CTR, click-through rate of my click-through rate of my set A. CTRA means what? Set A of customers. What is CTR of A? That is number of clicks I have got by number of ads that I have shown. Even you can go to this Google page. CTR is the number of clicks that you received divided by number of times your ad is shown, isn't it? Clicks by impressions, that is CTR. For example, if you had 5 clicks and 100 impressions, then your CTR would be 5%, isn't it? For example, let me say CA is the number of clicks by model AA, and NA is number of ads shown. Then what is about CB? Number of clicks related to group B, and NB means number of ads shown. If CTR of A, what is CTR of A? CA by NA, and CTR of B is CB by NB. If CTR of A is less than CTR of B, and I run this experiments on multiple days, let's assume I run it on day 1 and got CTR of A is less than CTR of B, and I run it on day 2, same thing, so on and so forth, then I know that my model MU is better in predicting which ads to go to which user, because I'm getting more clicks, which means I'm generating more money. So first I will start with 90-10% split. 90-10% split. Oftentimes what we do is, oftentimes we start with 90-10% split, even 95-5% split in some cases. We send 95% traffic to A, and with the old model, if new model is performing better for a couple of days, let's increase the percentage of traffic to 90-10%. If you are you can increase it to 90-10%, and slowly do 70-30 and 50-50. Eventually I'm very sure that yes, my new model MU is performing better than old model. When I am fully sure of it, my old model will get 0% traffic, and all the traffic goes to my new model goes to model B or new model. How do you compare CTRs? Comparison of CTRs is not that straightforward. Just try to understand these things. I will continue my discussion on A/B testing in my next lecture also. Thank you very much.